Okay, now look, this is the problem from last class which is unsolved. Now we can see how to solve it. If you read the question, uh, the current uh, is written there, the current voltage characteristic the current voltage characteristic of a silicon cell exposed to the direct sunlight at 12 noon in Florida during the midsummer is given in the figure. So this is the solar PV panel cell characteristic curve, which is the voltage versus current characteristic curve. And how it is formed, it is told here that it is obtained, that the characteristic curve is obtained by placing different size of resistors across the two terminal of the panel and measure the resulting current and voltage, and then they have implemented. Now if you go with this, the idea is like this. This is the sun, this is the solar panel, for example, and solar panel, the sunlight is falling on the solar panel, as you all understand. And what it does actually, the solar panel is producing the voltage at the two terminal of it. And nowadays most of you know that, and one is a positive terminal, one is a negative terminal. If you can go in any solar panel on your rooftop or wherever, you can see something like that. So this positive terminal and negative terminal of the solar panel is working like a battery. Actually you can think that this is a battery source. So it is producing the voltage over here at the two terminal plus minus. When the sun fall on it, then the silicon excited and it produce the electricity at the positive terminal. So it is a DC source, like a DC battery. So it is giving you the voltage at this terminal. And what they have done, they have connected a, to measure the current, they connect a ammeter, and to measure the voltage, they connect the voltmeter. But this two terminal they connected with different uh, according to them different resistor. So variable resistor can put, and then different values of resistor is connected to the panel, positive negative terminal, along with a ammeter and a voltmeter. This is the voltmeter, you can just take it as a voltmeter, V, and ammeter A. So the voltmeter is measuring the voltage and ammeter is measuring the current. This is what they are actually doing the experiment. In those days, long time ago, actually they have done this experiment. Now you can do it at home. And in Florida, they have done this experiment in the mid-noon, because in the mid-noon, that is the maximum sunlight fallen on the earth. That means the AMD, air mass density at that time, is 1.5. Yeah, the intensity of the sun is maximum at that, the highly maximum irradiation at 12 noon. That's why they have done the test at that time, and there's a maximum performance of the solar panel can be obtained. So what they did here, at different values of resistor they put, and maybe minimum value is 0 ohm, maximum value is infinity ohm. So they put in between minimum to maximum some couple of resistors, and then what happened when the resistor is connected there, a current will flow through this, and then it is flowing like this, then this is a complete the circuit. And they take the measurement of the current, ammeter measurement and voltmeter. These two reading they used to take, and they make a chart like a resistor, different resistor versus voltage and current. Voltmeter gives you the voltage, current, and the current meter is the current. So they given the, they have taken the reading. According to the reading, they start from 0 ohm, they go up to infinity ohm, and in between they put different values. And they got the value for the voltage and different values of resistor. So up to this everybody should be cleared. Now if we start from the first value, that 0 ohm, first time if you put R equal to 0 ohm, what I mean is I'm just taking it off, and then you can just think like this, that if R equal to 0, R equal to 0 ohm, what does it mean? I'm talking the first one, the first value. If you put R equal to 0 ohm, then what does it mean? If R is 0, what is this called? That means this there will be no resistance. No resistance
Yes, sir.
means this is short circuit.
Short circuit.
Yeah. So this is what we initially, if you consider that R equal to 0 and it is short circuit, that means there is no resistance here, only a direct connection there. So what will happen in that case? In that case, the current and voltage condition, if it is short circuited, then what will be the voltage reading at that time? If I ask you, the voltage will be what in that case? Voltage will
0,
be
sir.
0. Good, because the current I flow is there, so I into R, so I whatever the, then I will be I. R is 0. Since the resistance is 0, then the whole voltage is 0 volt. So you are getting 0 volt here. Uh, okay, now you're getting 0 volt here. Okay, and whatever the current flow in that case, the emitter is going to read the current, and that current will be what? If this is 0 resistance, no resistance, what does it mean? Short circuit means
Infinity.
a lot of current. No, infinity, yeah, you are right. In general, we are getting from the theoretical values infinity, but the
The
PV
current
panel,
will not
yeah,
change.
limited. No, the PV panel can provide you the maximum current, that is called, because it is shorted. If you short it, the current flow through the short path is normally called short circuit current. So we can say this is the short circuit current, which is the I max, maximum current can flow. And according to the PV panel rating, it is different for different company PV panel. If you go to electro-solar company in Bangladesh, you get the, let's say this is a 100 watt panel. So you will get the short circuit current or maximum current value for electro-solar is, let's say, 5 ampere. And if you go to some Rohima Fru's company, then you can see their PV panel is giving you maximum current is 6 ampere or 5.5 ampere. So company to manufacturer, this can be varied. So PV panel maximum current is known as the short circuit current. So we can say that this gives you the I short circuit. I can tell like that. So what happened when you are giving the 0 ohm resistor means it is the short circuit condition, right? You understand it. So short circuit condition, you are getting the voltage and current like x-axis, y-axis. That means you are getting 0 and I short circuit like that, something like this. Okay, so this is what the short circuit case, if you apply, then you can get. Now if we go for the, this is a minimum resistance if you apply. Now if we go for the maximum resistance, which is infinity, let's say in Florida they have applied the maximum resistance. Now in that case the maximum resistance means you can see that the thing will be not like this. Now it will be something else. That means R will be here. In that case, what? Maximum resistance, this means R equal to what? Hey, what happened? R equal to what? R is
Infinity.
infinity
Infinity,
ohm,
sir.
infinity ohm resistor. So infinity ohm resistor means the circuit is what? That is a question. The circuit is
Break, sir.
no, infinity means it is open. That is means infinity. Last class I show
There
you.
will be no
Yeah,
current flow.
current flow. Yeah, Infinity means high resistance. High resistance means what? Open. There will be no current
Yes, sir.
flow. This is
Yes, sir.
what do you call this one? Short circuit.
Open
No,
circuit,
sir.
sir.
Open
Open circuit.
circuit. So this is open circuit case where I is what? What will be the current
Zero.
flow? Zero. So I
Zero.
is 0 ampere. So it is
Zero.
your open circuit condition, and I is 0 ampere. And what about the voltage reading? I is okay,
Also
0.
infinity.
No, this is the
No,
question.
sir.
Point five.
Equal to what? Listen, this is
Equal
a
to
very,
voltage source, sir.
yeah, exactly. This is a critical situation. The voltmeter reading will be what? That is a question. This is called, uh, this voltage is going to call here VOC, open circuit voltage. That the voltmeter reading will be open circuit voltage reading. Now,
Yes,
if
yes.
you look, if you uh, if you see this point of the voltmeter is connected here, and that point is, if you come ting ting ting, you come here up to this, and this point of the voltmeter, if you come ting ting ting, come to this point, that means what? This is a short path, right? It's coming back here, and this is a short path coming back here. Actually, voltmeter one point is connected here, means is connected to the positive terminal of the PV panel, and voltmeter this point connected here means is connected to the negative terminal of the PV panel. Do you get it?
Yes, sir.
Okay.
Yes, sir.
If the voltmeter terminal connected to the positive of the battery and voltmeter is connected to the negative terminal of the battery, then voltmeter reading will be what? Is a battery voltage, right?
Yes, sir.
Yes,
Yes,
sir.
that is the voltage V. It's a open circuit voltage we call, and that is VOC. V is VOC. This is your VOC. The battery voltage is battery voltage. What we can say voltage VOC actually. The V will be VOC. We can call it like that. The battery voltage or open circuit voltage. We can say the open circuit voltage is the V battery. Not battery. This is the PV panel open circuit. The PV panel voltage. Okay, so, or I'm just telling you battery voltage or something like that. PV,
Source voltage.
yeah, source voltage like that. Now source can be whatever, right? Good. So this is what we can say. In this case, we are going to get the PV panel, so I'm just writing PV. But what happened then? The voltage here, the PV panel voltage or battery voltage, if it is a 12-volt battery, if it's a 5-volt battery, this is straight away come to that value here. So you are writing here in general case is a V open circuit voltage you are getting at this terminal when R is infinity, when it is open circuit. So the point is coming here, the VOC and 0, x axis, y axis point. Now why I'm writing like this? I'm writing like this. Look at it. This is V1, which is x, like x-axis, and y, I is just like y-axis, you can imagine. So it is x-axis, this is y-axis. So x1, y1, x2, y2, these are the points I'm talking about. So in order to draw the thing on a graph like this,
Sir, I
x-axis,
want to ask a
go ahead.
question.
Yes, sir, please go ahead.
Sir, if there is no current flow, will there be any voltage or
Yeah,
the
if there is no current flow, that's what I show you. If there is no current flow, it's open, then straight away the reality says that the voltage at this two terminal will be straight away the voltage of the battery terminal. Now, when you bring a battery from the market and I tell you, hey Dax, what is the voltage of the battery? And you will tell me this plus minus two terminal point, the battery is 12 volt, right? You tell me like that, because how you
Yes,
are
sir.
connecting the voltmeter and you can show me, yes, battery. How you check it? Just connecting a voltmeter to the terminal. Isn't the same thing here? This voltmeter is actually connected to the battery two terminal here, isn't it?
Sir,
Yes, sir.
when we connect the voltmeter, doesn't the electricity flow between
No. Oh
voltmeter?
yeah. When
Go through the
you connect the voltmeter, yes. What is that?
electricity doesn't
Flow through the
go through
voltmeter,
the,
yeah, through the
yes,
voltmeter.
sir. But
That is a separate issue. That is the construction of the voltmeter. we have
But
a
here, sir, we are not using any current flow, so there shouldn't be
no,
any
no, no,
voltage.
no, no. I'm not talking. If I tell you what is the voltage across the resistor, we are talking about, right? Or it is ohm
Yes, sir.
into resistor. That's a undefined because it's infinity into zero is undefined. But what we are talking about uh, here, what is the voltage at the voltmeter reading? We are talking about the ammeter reading and voltmeter reading. Try to get
Okay,
my
sir, I
point.
understand that.
So
Yes, sir.
voltmeter reading is giving you the voltage of the battery terminal voltage or PV. That is called open circuit voltage. Remember,
Yes,
in
sir.
future, every time you will be asked this question. That means when it is open A and B, you have to understand this is battery positive terminal, this is battery negative terminal.
Yes, sir.
So if I say what is the voltage, what will be the A and B voltage? That means what will be the voltage across the battery terminal? It's a battery voltage. So that is what
Yes, sir.
open circuit voltage as known as. So you should keep
Yes,
in
sir. I
that way.
understand.
Okay, don't
I
apply the
understand now, sir.
theory.
Thank you,
Theory,
sir.
yeah, it's fine, no problem. Now let's come back to the. This is a concept of open circuit voltage. Remember, and another one is short circuit current. These two concepts we need to use again and again in future, remember, so you can see that thing later. Now come back to the point. If we put and then the Florida man, what he did, he put a resistor here, not infinity, not these two things they put, and then he put some different value. Let's say R equal to 100 ohm, R equal to 200 ohm. As you saw in the problem, they put what do you call that, placing different size resistor. Different size resistor means like that. Then they put 100 ohm resistor, they put 200 ohm resistor, and a 500 ohm resistor, and so on. Now every time they got the value here, 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 like that, right? Now can you tell me the voltage and current value they are getting for 100 ohm, 200 ohm, 500 ohm, which value gives 0 volt or 0 current? Will it be 0, or this will 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 be 0, or something else? uh, any one of them will be 0. Which one? I mean the voltmeter reading and the ammeter reading. This is a question is voltmeter reading and ammeter reading. So if you put 100 ohm uh, I'm sorry, I'm having a phone call from just from the dean. Just hold on 1 second, please. Okay.
Sir. Okay, sir.
Okay.
Okay,
Okay.
sir.
Hello. Assalamu alaikum. I'm sorry. I already started the class. I'm sorry. So should I call or shall I call you later? Oh, I'm sorry, Ashraf. Oh, okay, okay. Later on, I'll talk to you later. Thank you. Okay. Hello. Hello. Can you hear me? I'm
Yes,
sorry.
sir.
It's a different call. I'm
Yes,
sorry.
sir.
Okay. Now let's come back to the point. Uh, what we can say that it's 100 ohm resistor, 200 ohm. What is the answer? Answer is none of them are.
None of
Yeah, none of them are 0, because if you put 100 ohm resistor here, some current cannot be 0. Some current will be flowing, right? Hey,
yes,
do you
sir.
understand it? Okay. If
Yes,
some
sir.
current flow, if there is some value, then resistance 100 into that current, that means voltmeter got some result for some reading here, right? Voltmeter also cannot be 0 because this is I into R. So if there is I, you get some value, and R is 100, of course you get some value for voltmeter reading. So voltmeter and ammeter must got some value. It cannot be none of them are 0. You understand?
Yes, sir.
Yes, sir.
Yeah. Same way for 200, 500, whatever, everybody got some value here. I mean, none of them are 0 or infinity. All the values are there. So you get some point here, you get some point here, you get some point here, and no one will be 0. Must have some reading. Voltmeter and ammeter must have some values or reading. Like this, he applied different register, got different values, except the first one and the last one. First one, this is 0 and this is I short circuit. Last one, this is open circuit voltage and that is current is 0. But other values, none of them are 0. Must have some reading from the ammeter and voltmeter. All of you clear?
Yes, sir.
Yes, sir.
Good. Now if you go,
Yes, sir.
if you plot the first point is 0 short circuit. So 0 is here, this 0 short circuit should be here, 0 and I short circuit is the point on the y-axis, right? If you say X, this is y-axis, this is x-axis, then okay, I as a y-axis and V
Yes,
as
sir.
a x-axis. Then this is the point, and another point is the last point, which is this one. This one is V open circuit 0. It will be on the x-axis. So this point will be on the x-axis, like we can say V open circuit, comma 0. So this is the point on the x-axis, and this is a point on the y-axis. These 2 points we all understand. Now, if we go other points like 100 watt, 200 ohm, 500, flying tongue, lots of data. If you plot after getting the data in Florida, the experiment, he got the data and then the data are plotted, and then those points are here, 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 here. He found the points are here, 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 and here, 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 like that. He put the points and he found the points are located like that. And he joined the points. He found the curve is look like this. This is what the construction of his PV panel characteristic curve. This is your PV panel characteristic curve. Okay, where you can see this is the short circuit point and this is the open circuit point. You got it?
Sir, clearly.
Okay, if you understand, let's go back there. This is the curve he got. So this is the short circuit point, and this is the I'm sorry, I can show you here. This is the short circuit point, and this is the okay, a little bit pressure. Okay, this is the open circuit, this is the short circuit point. Okay, short circuit point, and this is your open circuit point. Okay, and then you can see here what do you call that, okay, and other points are here. He got, and then he joined them and he got the curve, PV panel curve, like that. Now if I hope that you all understand it. Now if I ask the question, that is they asked for what is the answer to the question, let's go. First question is, what is the value of the short circuit current I short circuit? Hey, what happened? Yeah, what is that? Yes.
3 ampere, sir.
3 ampere, sir.
3 ampere, absolutely correct, because this is the point, short circuit point, short circuit point, and this short circuit point is the 3 ampere. So it is the point which is actually 3 and 0 point, which is short circuit current. I short circuit is this 3 is the I short circuit. So your 3 ampere is the answer to this question, short circuit. Very good. Now you can see very clearly. Can you answer question number B?
0.5
volt.
I'm sorry.
0.5
volts.
volt. Yeah, V open circuit is 0.5, but I will not give you marks. The reason is, if you look at this carefully, is it 0.5 or more than 0.5 or less than 0.5?
So
Less than
0.49, sir.
Less.
Yes, sir. So those who write 0.5, they will not get full marks. So full marks means it will be 0. Other than that, any value. So some of you said, sir, 0.49. Absolutely, 49, 48, whatever you write, all are correct. So you get full marks then. But 0.5 is wrong.
If we write approximately 0.5 volt.
No, not approximate. There's no approximation. It must be less than 0.5. So you must write any value less than 0.5, like 0.4999999, also you'll get full marks. And no
Sir, if
children,
we just
no,
answer
no,
it like
no,
this,
no, no approximation here. It is clearly visible that the point meet the x-axis, which is less than 0.5. Are you clear?
yes, sir.
Yes,
But
sir.
I was
Yes,
asking
sir.
about
No,
that.
you are asking approximately means your marks will be approximately reduced.
No,
Your
sir,
return.
I was not ac- asking that question. Now I was asking that in the exam, do we just write 3 ampere and we will get full marks, or do we have to explain something a little
Oh,
bit?
no, no, no. You just write the open circuit voltage is 0.45 from observation. So you are getting it. So you can straight away write. Let's show that like this way. Or just you can write the answer is V open circuit is 0.45. You get full marks. No need to explain anything here. I am explaining the whole thing because this is very important thing to know. Actually, this is the reason, because the whole world is moving towards renewable energy with solar panel. Or is the first time you heard in your life solar panel today?
No, sir.
Okay.
No,
Now
sir.
listen, next question is estimate. Now is the approximation comes, because here is the question estimate. What is the estimation? Maximum power. This is very important for solar panel also. In the solar panel, maximum power 100 watt or whatever, what is the solar maximum power you are getting? That is the question here. And where is the maximum power? That is what, if you want to find, look at it, where is the maximum power? That one,
Turning point of the curve.
yeah, that is you get. But if I ask you from your observation, this point, what is the power? Any children can tell me?
Zero, sir. Zero.
Zero, sir.
Zero.
Yes, it is 0. How you know?
Sir,
Sir,
P
I
EI,
Voltage is
sir.
zero.
P, which formula? P equal to I
Sir,
square
I
R.
P is equal to
sir.
EI, sir. EI.
Yes, EI, good. EI, and this is becoming 0 because your V is 0. Current is short circuit current. That means your 0 into what? 0 into 3. Oh, I have written this way, right? This should be 0 into 3. This is short circuit current, not this one. I think you know that. So I short circuit. Okay. And this value is your 0.49 or 48 and 0. This is the point, and that point is 0, 3. So 0 to 3, that means 0 watt. And what is the power at this point? Can you tell me?
Zero
Sir,
as well.
zero
Also
watt.
0 into I means is 0.48 into 0, also 0 watt. So both cases 0 watt, because current 0, voltage 0. That's why the power is 0 at the beginning, at the end power is 0. So definitely maximum power should be in between somewhere, ting tang ting tang. One of your friends said that in the curving point. Yes, it is normally you can see in the PV panel. You will get it in the current, but here you have to show in the exam how, otherwise you cannot get it. So any point, if you can consider near the turning point, like say 2.5 is giving you some value here like this. Okay, so if I get, what is the power here? Power is what? Hey duck, what is the power here? This one is
Sir,
what? Let's say any value. This is 2.5, and into this one we can say point what? Any 0 point?
0.25, sir.
No, 0.25 is here.
No, sorry, sir. 0.3.
0.35.
30.
0.3. Okay, fine. 0.3 is 0.3 or a little bit different. 0.3. Okay, 0.35. Right. If it is 0.35, what is the value? Can you calculate? Anybody calculator?
Sir, 0.875.
0.875. Okay, just getting up a little bit. Okay, 0.875. Okay, if you get 0.875 watt, you are getting 0.87 watt. So we can say that, yeah, this is the power we are getting at this point, but you have to show that, yes, this power is, and as you say, curving point, it gives you the maximum power. So you have to prove it, otherwise I cannot accept it. So in order to do that, what you do, before that one point and after that one point, you have to calculate. For example, let's say you can go for here this point. Oops, okay, I'm sorry. Okay, you can just check this point. Okay, this point 2 corresponding to here, and you come down here, any point here. So what will be this power? If you go, you can say that this is 2, and this one, what is the voltage, can be 3.75. What is
40.
that? 4. So okay, 4. What is that value? Come like 0.4. What is that? Come on, is 0.8, right? 0.
Yes, sir. 0.8.
8 watt. So 1 point. Another point, you can just put it 0.25, ting ting ting, and you get it, ting ting ting. So what is that value? Approximately here is a P equal to 0.25, 0.25 into 0.25 is this value, the voltage. And what's the current approximately? 2 point, 2 point what? Any approximately 3, less than 3, right? It's less than 3. 2.5.
29.
2.8. 2.8. Okay. It is a 2.8. Can you tell me what is the multiplication give you? 0.25, 2.8. What is that?
0.7.
0.7. 0.7
Watt.
watt. Now, hey, listen. Okay, if you see among the 3 point, this middle point gives you the maximum, right?
Yes, sir.
Yes, sir.
Which is this point. That one you have to show and tell, yes, the estimation is this. We can estimate the maximum power is 0.875. How? By showing the other 2 points. If you go here, it will be much, much less. If you go here, it will be much, much less. And if you come here, it will be almost 0. If you come here, it will be almost 0. Yes?
Yes, sir.
Yeah, so we can say that approximately within the curving point, as your friend said, there's a curving, and the curving area, you get the maximum power. Yeah, it is fact. It is the case actually. So exact how much, which point gives you maximum, that one MATLAB or some other people can calculate and find it actually, where is the maximum point. But approximately within the curving nature, it is the maximum power located, and you have to show in the exam finding 1 point here, another point here, another 3 point, and among the 3 point, the maximum would be in the middle one, which will be in the curving area. I think that should be enough. The other point, if you calculate, must be less than that, no doubt, you can see. And at the 2 extreme, it will be almost 0. So it must be somewhere in the curving point maximum. That's the way you have to answer to this question. Anybody got any question, or we'll jump to the next theory class? It's all right, everybody clear?
Yes, sir.
Okay,
Yes,
let's
sir.
go. Yeah, a bit faster. All right, then we are jumping to the next. Okay, done. Then this is done. Then this is also done. Yep, this is also done. Now we can back to the topic that today we are going to talk about. All of you get fresh about what we are going to talk today. The thing we are going to talk today, I show you already. I have sent the, I think uploaded the, what do you call that, slide on the BOP, and you saw that. We're going to talk about the basic laws and resistive circuit. That is what our topic today we are going to discuss. Now, among these things, the first thing we are going to discuss is the basic definition of certain parameter of the circuit. That is what our first thing today. So among the parameters we are going to talk is, the first thing is node. These are the definitions of the circuit parameters. Now, what is node? What is branch? What is path? What is loop? These are the things we are going to discuss. Okay, before nodes, first of all, we need to know what is branch. The branch is very straightforward. Everybody understand. Branch is the element of the circuit or the component of the circuit. Elements can be active element or passive element. Either active element, passive element. Active elements are voltage source, current source. These are active elements. and passive elements are resistor, capacitor, inductor. Now, this branch means number of the branch means the elements. So if I ask you in this figure, hey, look at it. In this figure A, how many elements are there? How many branches are there? How many elements are there? Hey, what? How
Five,
many?
sir.
Five. Any
Five.
children? Yeah. Okay. All of you entered. Okay, it's coming on the way. Okay. Now let us go through the branches. Okay. Now branches. There are 5 branches, as you all understand in this particular problem. There are 5 branches. It's a very simple, and A and B is also the same circuit, only a different way it is presented. So if you go with the 1, 2, 3, 4, 5, there are 5 branches here as well. So anybody can easily tell me by looking at the circuit that how many branches are there. This is a number of elements. It's very straightforward, very easy. Now let's come back to the second one, is a node. Node, you remember node by definition, it is the joining point. Listen carefully. It is the joining point between 2 or more branches. It is the joining point between 2 or more branches. It is the joining point of 2 or more branches together. So if this is the scenario, then we can say, for example, this is number 1 is the joining point. This is the joining point of how many branches?
2.
2? No.
Sir, 4, sir.
3. 4, sir.
4. Okay, look at it. It is the joining point of this one, this one, this one, and this one. These 4 elements join together at this point, right? And that is why it is node 1. This is node 1. This is the joining point of 4 elements there. This is the node 1. And similar way, 2 is another node. 2, if I say, is a node. How many elements joining point this node?
4.
4.
4, sir.
4.
Okay, try to understand. This one, the current source, this register, as well as this register. This 4, the green branches are joining together and giving you the node 2. Is it okay?
Yes, sir.
Yes, sir.
Okay, now another node is there. What is that node?
3, sir.
Node 3.
Node 3.
Okay, good. Node 3 is another node here. The node 3 is the joining point of how many branches?
2
2,
branches.
sir.
Absolutely correct. Because it is the joining point of these 2 branches up to the yellow color you say. This is the joining point of these 2 branches. So there are altogether 3 nodes in this circuit, and this node 1 can be stretched like this one, the figure 2. This is the node 1, we can say from here to here, node 1, because you can squeeze them together and can get it back to this, actually, like sort of things. You can squeeze them into one and come with this thing, and you can come here, you can come here, the register, and another register, and squeeze here, another register, and come here. Squeeze them into these points also. 1, 2, and this is 3. Also, you can get it into this form and can say this is node 1, this is node 2, this is node 3. Or you can expand the node 1 like that. Why? Because over here in between there is no register, no elements, right? There is nothing within this circle I have drawn. In between from here to here, are there any register, current source, voltage source?
No, sir.
So this is fully shorted. So whole thing you can squeeze into one point. That is a node. So node can be stretchable or it can be squeezed. Doesn't matter. squeezed into this one, right? All this point is squeezed into one point. So this is node. I think all of you understand about the definition of node. Hopefully it is clear. Now the branch and node, what is definition? All of you understood. That is, we have, hey, how many nodes we have? What is the answer?
3 nodes, sir.
What? 3 notes.
How many nodes?
3, sir. 3.
3. Good.
3,
This is
sir.
1,
3.
this is 2, this is 3. The joining point of the branches. So there are 5 branches, 3 nodes in this problem. It is very clear. Isn't
Yes, sir.
clear?
Yes, sir.
Yes,
clear,
sir.
sir.
Yes, sir.
But so simple and so easy to understand. But if I give you a problem, after this I'll give you a problem on it, and you see 50% of you will make a mistake. Let us see how. Okay, now let's, before that we go for path. What is path? Path is, it is the, by definition, path is if you start from one node, if you start from one node, let's say you start from 1 and go through the other node and come back to the another node. So what is that? Is a 1, 2, 3 to 2. This is your path. That means you start from node 1 and go through the other node and go to the destination node without repetition. Listen, without repetition of any node. Have you repeated any node when you travel 1, 3, 2?
No, sir.
No,
Yes.
sir.
If no repetition, then it is called path. But if you go this way, let's say you start from 2, go to 1, 1 to 2, 2 to 3. If you go like that, then it is what? 2, 2, 1, 1, 2, 2, 2, 3. You repeated. Have you repeated? Hey, Dak, what happened?
Yes, sir.
Yes.
Yes, sir.
The
We
repetition
repeated.
is the 2. So if it is repeated, 2 is repeated, it is not a path. Path is, it cannot be repeated. Clear?
Yes, sir.
Okay. That is the definition of path. That is the, okay, I'm going to show. Okay, that's path gone. Now loop. Loop is very similar to path. Loop is something like this. I'm going to delete it, then you can understand better. Okay, loop is something like, if you start from one node, let's say node 2, and go through the other nodes, 1, nodes 2, 3, and back to the same node without repetition any node. That means you start from one node, which is 2, then go to 1, go to 3, then go back to 2. That means the first node and last node should be the same node. And there is no repetition. If there is no repetition in between, other than the first node and the last node, then it is called loop. You get the point?
Yes, sir.
Yeah, but if you see that the loop is coming like this, 2 is starting from 2, go to 1, sorry, go to 1 and then come back to 2, go to 3 and come back to 2 and meeting with the starting point. So what does it mean? You have gone this way, this way, this way, this way, this way, then this way. Okay, then this way, coming this way. That means you started from 2, then you go to 1, 1 to 2, 2 to 3, 3 to 1, 1 to 2. So first node, last node is okay, but a lot of repetition here, here, right?
Yes, sir.
This is not a loop. This red one is
Can
not
we
a loop.
say there is 2 loop?
You can say there are 2 loop. Like good point. Let's say here, excellent, beautiful understanding. Okay, you can say there are 2 loop. You can write like 1 loop. You can say like this. I start from 2, ting tang, and then come back to 2. It's a one loop, you can say. You can, another loop can be like this. For example, okay, you can start from 2 and come back to 2, for example, or start from 3, come back to 3. It doesn't matter. This is one loop. This is another loop. Yeah, you can say there are 2 loops like that. Another 3 loop also you can say in between, another loop also.
Yes.
Whatever. But the condition is that first point and last point should be same. In between there is no repetition. Then it is a loop. You can check. This is the definition of loop. So I think everybody clear about this path loop and all that thing. Now all of you be ready with an example without wasting time. Example 1, I'm writing, all of you note it down on your paper, class note, and then give me the answer a bit faster. Draw with me very fast. This is 1. Okay, 1. Okay, here 1, here 1, and this is a resistor here. There is a resistor here, joining here, and here is the joining point. You can just put it there as well. And here is the no, okay. Here is the joining point. Yeah. Okay, and then you get a resistor here, and another resistor here, another resistor here, resistor here, and you get a resistor here, another node here. This is the node point Ken, and Ken point here and here, and you get a source here connected here. Okay, now this is the thing, the current source. This is R1, R2, R3, R4, R4, R5, R6, R7, R8. Okay, these are the resistances and tung tang ting tang. Now question is find branches, how many branches there, how many nodes there. These are the question. Second question, 1, 2. The third question is third question is, if we move from, okay, first you find it, this answer. All of you, have you drawn it?
Yes, sir.
Yeah, now tell me, all of you tell me how many branches are there? Anybody? How many branches?
Sir, 9.
Okay, how you get 9? Okay, good. All of you.
8 resistance and
8
1
resistance
source.
and
Right,
one
absolutely.
source.
Very straightforward. 1, 2, 3, 4, 5, 6, 7, 8 resistor and 1 source. So altogether branches are 9. Any children also can answer. Very simple. How about
Yes,
nodes? Here is the question. 50% of you will be divided from the other 50%. Tell me the answer. What is that? Nodes. Anyone can tell me? 1 node. Good. 1 node.
No,
Hey, how many node? 1 node. Are you okay?
12.
Sir,
12.
4 nodes, sir. 4
6
nodes.
12
node.
node. Okay. 12 node.
Sir, 6
4
node.
node. 6 node. Any other answer?
Sir, 6. 6,
Yeah.
sir.
Okay. 6, 4, 12. Any other?
Sir, 6.
18 boys. 18 students. 6 years. 12, 6, 4. We received 4 answer. Any other answer? No.
Sir, 8.
8. Good. 8 answer. 8. Any other? Everybody should work out. And there is another dot I didn't draw.
8, sir. 8. 8.
8. 8. Okay. 8 like that. Okay. So you can see.
8.
Okay, fine. Now you look, all of you are divided because last time branches only 1 answer. Everybody agreed 9. But here node you are divided. This is why I told you that you make a mistake. Okay, now look at it, how we can get it. Node. This is the node
Yeah,
1.
the screen
This
is
is no,
blocked.
oh, I'm sorry. Yeah, okay. Thank you very much for reminding me. Thank you. I think you can see now. Please immediately let me know if any problem. And I have given my contact number. Also, some of you can just give me a voluntary call if any problem occurs. Okay, this is node 1. And here, if you look, this is ting tong in between all the things, squeeze into one point because there is no branches in between. So all this you can join together into one point, and that is node 2. This is the mistake most of you have done. And then it is node 3. This is node 4. Then node 5. Okay, and here ting tang, you got all this combined together as node 6. So there are 6 nodes, not 12, not 4, not 8. These are the 6 nodes. If you have any confusion question, you can tell me the question. If you know, then I am jumping here asking you question. You tell me, hey dumps, node 1 is the joining point of how many branches?
The two
2.
branches.
Node 1 is the joining point of 2 branches. What are they? R1, R2?
Sir, source and R1.
Source,
and R1.
Source and R1.
R1. This joining point gives you the node 1. Beautiful. Node 2. Node 2 is the joining point of how many sources? Jihad. Hey, Jihad, can you tell me? Node
Sir.
2. How many joining points? How many elements joining points? Node 2. Bit faster.
4, sir.
4. Tell me which 4. The source.
Sir, sir, not 2, sir.
Hey, node 2. Go. Tell me what is that?
Sir, R1, R4, R2, R3.
Excellent. So R1, R2, R3, R4. These 4 registers joining point is node 2 because these are 4 joined together forming node 2. Everybody understood?
Yes, sir.
Yes, sir.
That
Yes,
means,
sir.
yeah, in between there is no resistance, no source, nothing. So I can easily delete this thing. And we can say that there is only one node, that is node 2, and it is a joining point of R1, R2. Squeeze, I'm squeezing all the points together. See, and this got, right? Same thing. Do you get it now?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
I'm squeezing all these things into one point, and these are the 4 points. That is node 2. Node 3 is the joining point of how many elements? Akib Hussein, bit faster, Akib.
Sir.
Yeah, how many points? Hey Gum, can you is the screen blocked?
No, sir.
Okay, go.
No, sir.
Akib Hussein, you tell me what is the answer. Node 3 is the
Which-
joining point.
It's R6, R5, and R7.
Tell me again.
R4, R6, and R5.
Why you say R7? Okay, good.
It was a
So
mistake.
these 3 node points are the these 3 elements. Okay, node 4. Akib again. Node 4. How
Sir.
many?
Node 4 is R6 and R7.
Are you okay? Tell me again.
R6 and R7.
Where are say? Is it R6?
Sorry, sorry,
Oh,
sorry,
you're,
sorry, sorry.
you're making a mistake here. R6. This is R5. It is R5. Now, node 4 is the joining point of what? Akib?
5 and R7.
Yeah, R5 and R7. Akib again. What is
Sir.
the node 5? Joining point.
R6, R7, and R8.
Good. Excellent. I think you understand. Now, Bipro Bhattacharjee, can you tell me what is node 6 joining point? How many elements? Bipro? Hello. Oh, can you hear me? Yeah, good. Go ahead.
Yes,
It's a joining point of how many elements, Vipro?
sir. R8,
Good.
sir. R2,
R2,
R3, R1,
R3, and
R1,
where is R1?
R1.
R1 is far away.
Oh, sorry, sir. Sorry.
You are correct. R8, R3, R2. R2, R3, R8, and another one. What is that? This side, this side.
Uh,
Source.
It is connected to what? R1.
sir. Sir, I1, sir.
Right. It is I, not I1. It is I, the source.
I, sir.
Yeah, good. These are the four. These are the four elements. It is the joining point. So this way we can say that there are altogether 6 nodes, and the 6 nodes are like this. I think that's great. I think all of you understand it, and other things are very much it's clear, because the node and what do you call that, path and loop all are very clear to you. I hope that you understood those, so we don't need to waste time for that. Now we can jump to the next topic, which is very much familiar in your HSC. You have already started. What is that? The KCL, Kirchhoff's current law. The Kirchhoff's current law, nothing new. You know that it is the algebraic sum of the current entering at any node is equal to 0. So if you look at this, okay, look at this diagram. It is a node point of 4 current coming from 4 branches. Okay, if I ask you to go like this, okay, here in this example, if you look carefully in this example, if I show you this, that what do you call that, a current is flowing through this branch in this way is IA, right, in IA, and the current flow through this branch is IB, and the current flow through this branch is IC, and the current flow through R2 is ID. Okay, so what is this? This is IA, this is ID, this is IB, IC, and this is IB. So this current is what? IB, and this is IC, this is IA and IB. So can you see this thing?
Yes, sir.
Okay, now if I cut it here, this is your IA, this is your ID, this is your IC, this is your IB. Now if I cut here like this, cutting means what? This this red line, you can see from this thing, if I cut it from here, it is what is that? IA, IB, IC, ID. All these 4 currents are coming through the branches like R1 resistor, R2, R3, and R4. These 4 resistance currents are joining at point 2. That red circle, you can imagine, this is that red circle, right? I am taking it from,
Yes, sir.
this is the node number 2. You can imagine node number 2 is this one, where the current coming from IA, IB, IC are different branch current. So if this is the scenario, then Kirchhoff's current law said that algebraic summation of all the currents are equal to 0. So algebraic summation of all the currents means this is IA plus IB and plus IC as ID. But since these are in opposite direction, it should be negative. So it is the thing here, IA plus IB, and it should be IC plus ID, but it is minus because of opposite direction. That's why the minus ID minus IC is coming there. So it is the algebraic summation of all this current together equal to 0. Now if this arrow marks is that way and if the arrow marks that way, then all are positive, 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 like that. But this is opposite, that's why it is a negative coming there. So this is how the you know that already, that what is the current coming there. So if I say that IA is, let's say, 10 ampere, IB is 5 ampere, for example, and IC is your 3 ampere. And if I ask you what is ID will be, can you tell me?
8 ampere.
So 7.
What? 8 ampere?
7 ampere, sir.
7
7
ampere.
ampere, sir.
Is it correct?
The 12.
12 ampere.
12.
Okay, now let's come back to the point how we can find it. Because first thing is, we have to go for the values for IA is a 10 ampere, IB is what? 5 ampere, then IC is minus, what is that? 3 ampere, and this is ID equal to 0. So you can find your ID here. What is that? ID equal to 12 ampere.
12, sir.
So it is 12 ampere. From there directly you can say. So now this is what the Kirchhoff's current law you all studied long time. Now you can consider according to the direction, and the values can be different. For example, I can give you an example, then you can understand it. Everybody solve this problem on the Kirchhoff's current law, then you can understand it, how to find the solution. It will become clear. Okay, so all of you please copy example on KCL. KCL. Okay, now example is something like if you say that this is a okay, so this is the network, and here the current flow through this is let's say I can say this is I1 equal to, let's say, 10 ampere. Okay, and another current is flowing through this resistor is I2, I3 equal to 12 ampere. 12 ampere, and the current here is I2. Okay, I'm going to write this cut. I'm going to write another one, I5. I4, I5. I5 will be just like this. Let's say I5 equal to, let's say 8 ampere. If this is the current flow direction and this is the values, now the values what you have to find are these. Let's say this value I can write I2, this value I4, this value I6, and this value I7. Okay, the green letter, the green current, you have to find the values of the green current. That means you have to find the values of I2 equal to what, I3 equal to what, I'm sorry, I4 equal to what, then I6 equal to what, and I7 equal to what. These are the values you have to determine, and using Kirchhoff's current law. This is what you have to find. Now the values are given, the red current I1, I3, I5, these are the current given. Now how can you find the I2, I3, I4? Like that question is coming now. Now first thing is what you have to do, listen very carefully. You have to assume the direction of the current flow arbitrarily, no problem. Arbitrarily you can assume the direction of the current flow. So arbitrary current flow direction is, assume that I4, I2 is coming like this. I4, it is coming from, yeah, from here to here, it is like this. Assume assumption, and these two current coming, and this is going like that, and this current and this current joining and going out to I7. You understand it? Oh, we are going out within 10 minutes time. Okay, can you see the assumption of the green current?
Yes, sir.
Yeah,
Sir.
arbitrarily, any way you can draw. You can draw the other way around also, the green current, no problem. But assumption is like this. Now, if your direction is correct, then you will get the positive value. The current value will be positive. If your direction is, if your actual direction, original direction is opposite, then your value will come negative. That means if the value I6 is coming here, 3 ampere, after calculation you get 3 ampere, that means your direction is okay. Positive direction is okay. And if you get minus 3 ampere, that means your direction should be, actual direction should be in opposite direction. That's the reason why you got minus sign. Okay, this is the way actually you have to get it. Now you arbitrarily assume this direction. Now you have to find the solution based on this direction. Now look, you assume that how many nodes are here? You can assume the nodes. How many nodes? 1, 2, 3, 4 nodes. KCL applied, as we saw in the definition, any node, and node 2 we considered, at node 2 summation equal to 0. So algebraic summation of all the currents at node 2. Hey, what is the current I have written here? Come on, man. IA plus IB, dumb. IA and IB is coming in, and ID and IC is going out. Since it is going out, that's why it is minus IC minus ID equal to 0. You understand it? This is the definition of KCL node. Incoming current positive, outgoing current negative. Is it okay?
Yes,
Yes, sir.
Now let's go there. And it is a node, we can say A, B, C, D. 4 nodes. Now, if you apply at node A, what is the KCL at node A? At how many KCL? Hey, how many unknown you are? How many unknown? Hey, Tom, how many unknown there? What is this?
Sir, one.
One unknown.
I
Find how many find? How many things you have to
2.
find? 2. Are you
Oh.
okay? Yes.
Now, who is
Four, sir.
six?
4.
Now I see one girl is shouting, and that's all you are listening. You lost your concentration. I'm asking you, how many current you are finding here? You said 1 current.
Sir, four.
4 current. You need how many equation?
4 equation.
4 equation.
equation.
Okay, 4 equation comes from 4 KCL. 1 KCL give you 1 equation, right? This
Sir,
equation,
yes,
one
sir.
equation got from 1 node, 1 KCL at node A. KCL, so one KCL gives you 1 equation. So you need 4 KCL, and a 4 KCL comes from 4 node. 4 node is node A, node B, node C, node D. There are 4 node: node A, node B, node C, node D. 4 node will give you 4 KCL. 4 KCL gives you 4 unknown. You okay?
Yes, sir.
Good.
Yes, sir.
Hey, some of you are not following me, is it? Okay. Now look at it. If you go for KCL at node A, how many currents there? Bit faster. At node A, how many
3.
currents? 3.
3, sir.
I1, I1,
current.
I2, I3. I1, I2, I3, right?
Right, sir.
So
Yes, sir.
I1 is coming in. So you write I1 is in, positive. And I2 and I3 is going out, means what? It will be minus I2 and minus I3. Do you get it?
Yes, sir.
Yes, sir.
And equal to 0. That's what you got. Now, if you substitute the value, I1 is 10, minus I2 is I2, you have to find. And minus I3 is what?
12.
12. What is the value of I2? Can you find it?
-2.
Minus 2.
Yes.
First
I2 is minus 2. I2 is minus 2 ampere. So your answer I2 is not, I2 is here, will be minus 2. This is the answer to I2. That means what? It means the assumption of I2 direction is not the original
Yes.
direction, or direction should be the opposite.
Yes,
So
sir.
if you write I2 equal to 2 ampere, then your arrow mark should be opposite, like that. If you put your
Yes,
arrow
sir.
mark this, then the -2. That's the answer. Answer is -2 means your arrow mark, you can keep it like this, no problem. You get full marks. This is the way the current should be determined. Similar way, if you go with B, KCL at B, hey, can you tell me the equation a bit faster? Anybody?
Sir,
Yes, sir. I3.
I3
Sir,
I3
I3 plus
equal to
I5 plus
I4 plus
I4 is equal
I5.
to 0.
Oh, you
I3
dumb.
minus
I3 minus
I2.
I2.
I3 minus I5. I5.
Why you say I2? You kill
I-
yourself. I5, then minus
Minus I4.
I4. The rest of you take a lollipop and sleep, and equal to 0. You all understand it?
Yes, sir.
Okay, good.
Yes,
I3 equal
Yes,
to
sir.
what? What is I3 value?
4 amperes.
Oh, you dumb.
4 amp.
12.
Sorry, I4
Sir, 12,
I'm
sir,
at
12, 12.
12. Are you in this world or where? I5 is what?
8.
8, sir, 8.
8 minus I4. You have to find it. Dark head. All you're dumb. Okay, now what is the value of I4? Now you tell me I4 equal to what?
4 amperes.
Four.
Yes.
Four.
Somebody is just memorizing the thing, has just told me 4 ampere directly. What I'm asking you, don't care about it. Just give me the answer the wrong way. So I4 equal to 4 ampere. I4 4 ampere, good. So I4 is 4 ampere. So your answer here coming as 4 ampere. So your answer 4 ampere here. I4 is 4 ampere. This is 4 ampere. This is -2. Good. Now C and D, these are the two. The C I'm going to go. If I go C, KCL, what is the KCL here? At C.
I2 plus I4 plus minus I6.
Minus
Good.
I6.
Excellent. I2 plus I4. Anybody got question? Tell me. I4 minus I6 equal to 0. Good. And I2 equal to what? I2 value?
Minus 2.
Absolutely. You have to put -2, right? I4
Plus 4. Plus 4
plus
ampere.
4 minus
Plus 4.
I6. You have to find it, isn't it?
Yes, sir.
So
Yes, sir.
waiting, what is I6? I6 is equal to, tell me what is that?
2, sir.
I'm sorry.
2
2,
ampere.
sir.
2. I6 is a 2 ampere. Okay. So I6 is 2 ampere. So your answer I6 is 2 ampere here. So your answer is 2 ampere. I have written mistakenly this as assumption I told you, right? This is not the thing. Okay. Hey, what happened? 3 ampere, I just told you for your understanding. This is not the answer. Are you thinking like that? This is the answer. 3 ampere. No.
No, sir.
Okay, good.
No, no.
So just don't make a mistake there. So 2 ampere you are getting here. Finish. Now the job is done. Go back home, is it?
No, sir.
What is
No,
that?
sir.
Next what?
I7.
I7 is
I7, good. I7 you have to find here. Which node?
D.
Node D, good.
Sir, no.
Node D is going to give you. So node D I can write here, KCL from node D. Anybody tell me KCL?
I6 plus I5 minus I7.
Good. I6 plus I5 minus I7. Excellent.
7.
Yeah, I7 equal to 0. Good. Now I6 equal to what?
2, sir.
2,
I6 2, right.
2 ampere.
Plus I5 is what?
8.
8 ampere.
8.
Minus I7 equal to 0. This is
9, sir.
now I7 equal to what?
10,
9.
10,
10,
sir.
sir, 10, 10, 10, sir, 10, 10, 10,
10
sir.
ampere.
10.
Okay. If it is 10 ampere I7, then you can see this is 10 ampere's answer. That's done. 10 ampere done. So all the 4 currents are found. This is completed. Now one thing you look very carefully. I think everybody understood, right?
Yes, sir.
Okay. Just check everybody in or what? Yeah, almost. Now, all of you just look very carefully. One thing that the total current coming into the circuit is what?
10 ampere.
10 ampere.
10
And the total current going out from the circuit is also
10 ampere.
10 ampere, because
10 ampere.
I7 is 10. So you can say this 10 ampere enter into the circuit and going out from the circuit, where the 10 ampere come from and where it goes. There's a question. Just I'm going to draw here. Okay, take it off. Okay, over. Sorry. Okay, you go there. Ting ting ting. This 10 ampere. Okay, and this 10 ampere is going out from here and coming here. Now there is something there, and that is nothing but a current source of 10 ampere. A 10 ampere current source is connected with the circuit, for example. So the 10 ampere is coming from the source into the circuit going out. Now, if this is the scenario, then which arrow mark of the current source will be in which direction? Is it correct?
No, sir.
Or you cannot see, is it?
No, sir.
Yes, we can
Okay,
see, sir.
can see. Okay, good. Now it should be what?
Opposite direction, sir.
Opposite
Opposite
direction.
direction.
That's right. So you understand it. So it is just think like that. Yeah, you are right that the current I7 is 10 because I7 is 10 because the current is going out. Sorry, it is not showing these things. Okay, because it is I7 is going out. So I7 is 10 means it is correct. But I7 10 ampere in and 10 ampere out. If you got somebody told me 9 ampere, if it is a 9 ampere, there's something wrong because 10 ampere enter and 9 ampere out, it is unbalanced. So it is not correct. So from here we can get it that yep, all answers are correct. So this is the way the KCL can be explained. I hope that everybody understood. Anybody got question can ask me. If no, then we are jumping to the next one. What is that? This is a KVL. Yeah, any question? No. Hey, Dax, what happened?
Sir, no question,
Yes.
sir.
No question. No question.
No
Means,
question regarding
okay,
KCL,
go for
sir.
the KCL. A KVL. You also did the KVL in your school life. Very much you are familiar with. KVL is the algebraic sum of the voltage around any closed path. What is closed path? I don't need to tell you because you already seen the loop and path.
Yes, sir.
So closed path is the loop. You look, last time KCL, I ting 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 ting. Let's go back. Here we go. Here, look at it, everybody. This thing is a node and this thing is a loop. This node gives you, hey listen, this node gives you the KCL and the loop gives you the KVL.
KVL.
And this is already, we have seen nodes, 4 nodes, A, B, C, D, 4 KCL. We got and found the, like we are going to see now the KVL, which deals with the loops. Loops or closed path. Path, if you write a closed path, the closed path or loop are same. Okay, I think then you understand it. I don't need to waste time here. So you can see now. This is the closed path. Why it is closed path? Look at this. Because if you start from node A and ting 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 go node 3, ting 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 node B, ting 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 node A. So start from A, go to C, go to B, go to A. Start from A, come back to A. It's a loop or closed path. You understand it?
Yes, sir.
No repetition of node. It is a loop or it is called closed path. Okay, if you understand that, closed path or loop is this one. So it is the algebraic sum of the voltages. So if you start from this and come back this and you see how many voltages are there, algebraic summation of all the voltages will be equal to 0. Hey, how many voltages?
Yes,
if you come from here and come back here, you are coming through how many voltages? One is your V.
3 voltage, sir.
Another, yeah,
Three,
that's
sir.
right. V3 and another one is V1. 3 voltages. V1, V2, V3. Right?
Yes, sir.
Good. Now, let us go with that. Now, let's come back here. These things we are going to go through the node like this. Let's say start from the ground. Normally, it's a ground or lower part. So you can start from here and, sorry, you come from here, start from here, come back here and come back here. Like that way, we can say. If you go that way and you come across the three voltages V1, V2, V3, so algebraic sum of V1, V2, and V3. That means V1 plus V2. Oh, sorry. I'm writing V1, algebraic sum of V1, V2, V3, V1, V2, V3. These three voltages algebraic sum will be coming here. Now, how we are going to go with that, V1, V2, V3, you can write V1, V2, V3, but question is, like last time, current in is positive, out is negative. But in this case, which voltage positive, which voltage out negative, this is a question here. Now, if you start from here, then you can see, if you go with in this way, upward direction in this way, then you can see the V1 first thing is coming. No, V1 first sign negative is coming first, then positive. But when you go over here in this way, then positive come first, then negative. Again, you come here. What comes first? Negative. Come first, then positive. So when you go in like this way and your negative come first, we call is voltage rise. And when positive come first, then negative, then it is called voltage drop. And in that definition dumps, V3 will be what?
Voltage rise.
Hey, rest of the
rise.
Yeah, rest of the dark. You understand or sleeping?
Yes, sir, understood.
Okay, it's a morning time. Okay, voltage rise because the minus sign comes first, then plus. So it is voltage rise. If you go like this, start from here and come back to this point, and then the plus, minus, plus, plus, minus, minus, plus. So voltage rise, voltage drop, voltage rise. Now, conventional way, we can consider only one way. Maybe we can all, throughout the whole semester or for this course, we'll consider voltage rise as positive. If you do other way around, no problem. But if one thing, everybody should be in unique direction, so it will be much more helpful for understanding. And if voltage rise positive, then voltage drop we should consider as negative. And here, yeah, and it is positive voltage rise. So if this is the way we do, then what happened? V1 will be what? Positive. V1 is voltage rise. V2 will be voltage drop, so it will be negative, and V3 will be positive because it is voltage rise. So we are getting the equation here as a V1 minus V2 plus V3 equal to 0. This is our KVL equation. You understand it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Excellent. Now this is all about your KVL. Everybody got the point very clearly because KVL is a very straightforward. Now, if I go this way, a little bit interpretation, carefully look at it. I'm going to take it off. So everybody, okay, I'm going to go with another page here so you can understand much more better. Okay, okay, here, if I go with this, now you look at it. I said this is voltage rise. Now 1, 2, 3, these things are unknown element. Now if you open the door of this black box, what is inside? Maybe inside we can see there is a you know, there is, this is plus and minus, means there is a, for example, there is a battery there inside, and the battery positive terminal here, negative terminal here. It should be like this. Let's say this is a 5-volt battery. What happened here? Battery positive, you know that a positive terminal is a bit bigger and negative terminal is smaller. So I have drawn like this. Do you, it make sense?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
Let's say I open the box 3 and voltage drop. Let's say this is a element, resistor element, we can see. And if we open the box here, for example, we can see another battery here, but negative terminal here, small terminal, and the positive terminal is a big terminal. So I can say this is plus minus. Maybe I can say this is 3-volt battery. Okay, so it's a 3-volt battery, is a 5-volt battery, means V1 is 5-volt and V3 is 3-volt, right?
Right, sir.
So if I say these are the elements and there is a resistor here, you understand it, the resistor is here, the resistance. Now, if I say, hey, listen, if I say that resistance is a 4 ohm resistor, any value for it is fixed. There's a color code, tell me 4 ohm resistor, let's for example. Now, if I say the KVL, we apply KVL and find the value of the voltage drop across the resistor. So what KVL says, V1 minus V2 plus V3 equal to 0. Hey, listen, what will be V2? V1 will be 5-volt. Yeah, go.
Sir, minus 4I.
No. I'm talking about the voltage. This is 3. Anybody?
So 8.
This is plus. V2 will be. V2.
Sir, 0.
What? Anybody?
8.
Why you say 0? V2 is 8-volt.
8 volt. 8 volt.
From the KVL, we have written the
Yes,
KVL
sir.
from this thing already. V1 minus V2 plus V3, right?
Yes,
Now
sir.
I open the box
sir.
and I saw that two voltage source are there and one resistor. So what does it mean? It means this is a minus plus plus minus. This a current is flowing through that. Listen, current is flowing through that. And why current flow from these to that? A to C, because this is higher potential, this is lower potential, right? Current flow from higher potential to lower potential. You know that. I think that's why it is plus minus. So if the current is I current is flowing through this. I current is flowing through that and from A to B through the resistors of V2. Now from KVL we found V2 is 8-volt. Fine. If I tell you, that means what? That means this voltage drop is 8-volt. 8-volt. Okay. So you easily understand now. 5-volt, 8-volt, 3-volt. So 5-volt minus 8-volt plus 3-volt is the KVL is the value now we got. If it is 2 batteries, then the other voltage we can easily find from the KVL. I think it's understood. Like the 3 current, I1, I2, I3, you add together. Yeah, I1 and I2 given I3 you can find. Like that, V1, V2, V3. If V1 and V3 is the battery voltage you got, so you can easily find the V2 from here, right?
Yes, sir.
From the KVL.
Yes, sir.
Now, if I ask you the additional concept I'm giving you here, what will be the current flow? Anybody can tell me.
So 2 ampere.
How you found it?
So 8/4.
Yeah, you apply the Ohm's law. Ohm's
Yes,
law
sir.
said, yeah, Ohm's law said the voltage V2 divided
So
by
there's a
R.
blockage. Sir.
Yeah,
There's a blockage, sir.
yeah. So, oh, block it there. Okay.
Sir.
All right, just 1 minute. All right. Now look at it. V2 is your 8-volt and R is your 4. You are getting here 2 ampere. So 2
Yes,
ampere
sir.
current is flowing. 2 ampere current is, hey, making sound. 2 ampere current, 2 ampere current. So everywhere 2 ampere current through the circuit is flowing. Got it?
Yes, sir.
Okay.
Yes, sir.
This is 2 ampere current from the circuit, closed circuit. The current is flowing 2 ampere. This is 2 ampere current flowing, remember. Okay, now everybody understood that this is the concept of this thing, that is KVL can be found in this way. Now, if I drop this thing here like this again for your understanding, just I got the battery here like this is a positive, negative, 5-volt battery here, and as we found R is 4 ohm resistor and this is a 3-volt. Now I'm going to do what? Look at it carefully. I'm going to revert the polarity here. This means I'm going to make it plus and this is minus. If I do it, then what will happen? This will be what? This will be big plate and small plate will be this one. I think you understand it. And if I say this is 3-volt, 3-volt battery, this 5-volt battery, plus minus. You understand the thing, and resistor is this.
Yes,
So
sir.
the current flow I is this way. If I assume, then plus and minus is a voltage rise. Now, if you apply the KVL, can you tell me V2 equal to what? Any tuck?
So 2.
V1 minus V2 plus. This one is what? The equation minus or plus?
Minus, sir.
Minus.
Yes, because this is plus and this is minus. The plus sign and minus sign is a voltage drop or voltage rise. V3?
Voltage drop.
Oh, excellent. V3 now voltage drop, because I have written this is positive. Change the polarity. Polarity change means now it is voltage drop, not voltage rise. So you are getting this. This is the equation now. Plus, if you go plus minus plus minus plus minus. I'm sorry, minus plus plus minus plus minus. So you are getting plus this. So the equation gives you the value minus V2. This is 3 equal to 0. Some of you told me V2 equal to what?
2, sir.
2 volt.
2, sir.
So, yeah, if it is 2 volt, this is a form. 2 volt, then what will be the current flow? Hey, Dax.
So 2.
2.4.
So 2 ampere.
2 ampere. You have a calculator, or are you all okay? How many people they are sleeping there? All 18 ducks are a pack.
1 ampere, sir.
1 ampere. You kill yourself better.
Sir, half it will be half.
0.5 ampere.
0.5 ampere.
0.5, sir.
After 1,000 years, all of you are doing what? Watching movie or what, looking at this? Okay, how you got V2? V2 by R. So V2 is
Yes, sir.
and R is 4. How come
4.
you say 2? How come you say 1? How come you say ting tang? You have a calculator, right? Okay, 2 by 4 equal to 0.5. When you didn't born, you learned it, right? 0.5. 0.5 is the current flow. 0.5, 0.5, 0.5. Do you all understand now?
Yes, sir.
Yes, sir.
All of you are dark-head. Okay, this is the current flowing through the circuit. Look at the previous circuit. How much current flow through the circuit?
Sir, 2 ampere.
2 ampere. And now how much current flow?
0.5 ampere.
0.5.
Okay, come on, listen. What is the difference between these two circuits? What is the change?
Current flow has decreased.
Sorry?
Sir, the current flow decreased because of the change of the polarity of voltage.
Battery,
source.
voltage source, right. So I changed the battery polarity other way around. Which battery? 5-volt battery or 3-volt?
3 volts, sir.
3-volt
volt
battery.
battery, sir.
Every duct should concentrate, otherwise you'll never understand anything. I am going step by step. Okay, good. If you rotate this if you interchange the polarity of 3-volt, you saw the whole thing scenario change. The current decreases because it is opposing now. 5 minus 3, 2, and then the voltage drop is coming 2 volt. That's why the current gone down to 0.5. This is what the KVL can give you the solution. Now, we are going to we are going to see one thing here. All of you look at it carefully. That is called power conservation. Power conservation rule means the total power total power delivered will be equal to total power absorbed. This is that means in a circuit, if you look at that, it's a battery, it's a resistor. Resistor R is, let's say, 4 ohm, and battery is, let's say, 5 volt, right? So what will happen? The battery is going to give the power to the resistor. So in this case, battery is going to, what is the current flow? Can you tell me, anybody from the circuit? If
Sir, 1.25.
How you do? 5 by
1.5.
1.25.
1.25 ampere. So 1.25 ampere current is flowing through the circuit. What happened? The battery is delivering the power or is absorbing the power?
So delivering.
Delivering the power. So power delivered by the battery. And resistor is what?
Absorb, sir.
And in the form of
Absorbing.
heat. Yes, in the form of heat, absorb. Now, if you want to find the delivery power, the battery is delivering the power. What is the equation? You know battery voltage and the current. What is the equation? Power equation. Three equation. Which
P is
equation?
equal to EI, sir. EI.
I.
Is
Good.
equal to EI.
Yeah, very good. Equal to what? Come on.
5.
Sir,
5
5.
volt.
And I equal to?
1.25.
1
You
to
got a
5.
calculator. Please use it. How much money you will spend for it? Faster. What's the
So
answer?
6.25. 6.25.
6.25 watt. Good. Now come back to the absorb power. This is the resistor. This is the I. You know. I and R. You know. What equation?
EI, sir.
Equation? EI.
Oh, I square R, sir. Sorry, sir. I square R.
Square.
I square R. Straightforward. Resistor means I square R. Okay. I is equal to what? 1.25
1.25.
square into R is 4. Now use your calculator, please.
6.25.
6.25. So this is the power you are going to deliver. So the absorb power and deliver power must be same, because the total if there is another resistor, another battery, another resistor, another resistor, another resistor, like sort of things, that means all the absorb power you have to add together. We call it summation of P absorb and all the delivery power P deliver. Then these and these will be equal. You understand it now?
Yes, sir.
This
Yes,
is
sir.
called conservation role in a
Yes, sir.
circuit. So power conservation in a circuit means what you have to do, you have to find the power individually, each of them. If there are 3 resistance, 3 power you have to add, find and then add PR1, PR2, PR3, PR3. PR2. Then you have to add all the 3P, and that is your P absorb, let's say. That is the summation of P absorb. Got my point? Like the battery power. There's a P, one battery, second battery, you have add them together. You get. Now, like that way, if you go, you can see here. In this case, hey, listen, look at it very carefully. I'm talking about the power conservation rule here. So tell me, according to that, this is one battery, right? P delivery, yeah, P 5 volt battery power. If we calculate, how many battery here? 2 battery, 1 resistance. So first battery, what is the power? Can you tell me? What is anybody from the equation? Bracket. 5 volt
Yes, sir.
battery
10.
power. What is that value?
10 watt.
How you got? What into what?
I
5 into 2, sir.
5 into
5
2.
into
Yeah,
2.
I into E means 5 into 2. You got 10 watt. Good. And another one is this one, right? P, another power is P 3 volt. P 3 volt. What is the power? Hey, Dax.
6 watt.
How you
6
got?
watt.
How you got 3 into?
Sir, 3 into 2.
Right. Good. I'm just going to redraw it here. It is 3 into 2. Right. So I'm going to show here your P3 volt equal to 3 into 2. 3 into 2 means 6 watt. 6 watt, and this is 10 watt. And now come here to this resistor PR. There are 3 elements. So 3 power you have to find, right? 3 elements there, 3 branches.
Yes, sir.
Okay, P4 ohm resistor. Which equation?
Sir,
I square R.
You can just
R.
better, yeah. If you find a resistor,
16.
yeah,
16.
if the resistor, it is better to mine I square R, which is how you got 4 square, I2 square, 2 square into 4, right?
Yes, sir.
Yes, and that
16.
is
16.
16 watt. Now, how many delivery, P delivery, how many battery?
2 batteries, sir.
2 battery. One is giving 10 watt, another giving you
6
6
watt.
watt.
6 watt. What is the total value?
16.
16 watt delivery. And P absorb how many?
16,
This
sir.
is P absorb. Yeah, P, the resistor which is 16 watt. So this is your P absorb 16 watt, and this is your P delivery, which is 610 watt, and this 6 watt. So 10 and 6 combined together, 6, and this is 16. So your delivery, this two battery delivery the power 6 watt and 10 watt together, and this resistor is absorbing the total power 16 watt. You understand it?
Yes, sir.
So
Yes, sir.
it conserves the energy. It's an energy conservation or power conservation rule you can see here. Now come here. Hey, all of you, this is the most critical time we are passing. So all of you concentrate. Now, what is the power here? Come on. Faster. What happened?
So 2.5.
2.5. How you got 2.5? 5 into 0.5.
0.5.
0.5 gives you 2.5. Good. 2.5 watt. And here it gives you what?
1.5 watts.
P3 volt is giving you, how you got to equal to
So
3 into 0.5.
0.5.
Right?
Yes,
Okay,
sir.
what is that comes? What is the value?
Sir, 1.5.
1.5 watt. Okay, everybody try to understand. If you do not understand, immediately let me know. Okay, good.
Yes, sir.
Now, another one is this resistor here, the power P absorb PR P4 ohm. Okay, so what is the value? P4
Sir,
I
9.
square R. I square R means 0.5 square into 4, right?
4.
What is the value?
1, sir.
1
Watt.
watt. 1 watt.
1 watt,
Hey,
sir.
you all okay? Now you go for P delivery equal to what? Come on.
Yes, sir.
What is the value?
2.5 watt.
2.5 watt.
2.5
Watt plus
plus
minus.
come on, what are you talking? This is the
Only
battery. One
2.5
battery,
watts.
another battery. These two battery. One is
Yes, sir.
2.5, another battery is what? 1.5.
5,
1.5.
sir.
What is the
minus
value?
1.5.
Why minus? I'm asking you, two battery delivering the power. What is that? 2.5, 1.5. What is the value?
Sir, 4.
Sir, 4.
4 watt. And
4.
P absorb. P absorb equal to what?
1 watt.
1
One watt.
sir.
Come to the so far you know the conception, you follow that. These two battery delivering 2.5 and 1.5. You're adding them 4 watt. So 4 watt, these two battery giving, and one resistance absorbing that power, which is 1 watt. But you are seeing here that this absorbed power delivery power is not equal, right?
Right, sir.
Yes, sir.
That's why you are telling minus plus dum. But you come to the normal process. Normal process is this two battery absorbs the delivery power is 4 watt and resistor absorb 1 watt. So you can ask me, sir, energy conservation rule fell. You should tell me that.
Yes.
In states like
Yes, sir.
Bangladeshi mentality, you are trying to adjust the value so that you get full marks. No understanding thing. Now listen, why you say minus, this you don't know, but to adjust the value, it is minus. That's it. Now listen, I'm
The
telling you,
polarity was changed.
no, that is not the way you can come up here. That is what I'm talking about. This is the most critical thing. In your in the exam, this simple problem you never expect in your life. Very complicated problem will be given and you have to solve it. But understanding and clear conception from here is very important. Now listen, this delivery power actually you are getting the summation of the two battery. This is not always the way you should do. If you do, then you will be in trouble like this problem. It is not the way you should follow that. Oh, there's a voltage source, there's a current source, so these are all delivery the power, so I add them and register all absorber. Not necessarily. That's why this method is not correct for finding the conservation to prove the power conservation rule. That is, all the battery, all the current source are delivering power and all the resistors are absorbed. This is not true. That's why you cannot do like that. All the battery power or current source power individual you find and you add them and tell them this is deliverable. No, this is not the right way. So what is the right way? That one I'm going to show and you can have a look. you have to go with the associate law. Associate law. The associate law can give you the answer to this question. So how complex is the system circuit? It's not a problem. You can easily find it applying the associate law. The associate law says that, look at it, that element is there and the current flow this way. This is the voltage plus minus V. This is I. And another one is like this. Current I is there, and this is minus, this is plus, the V. This is V. That means these follow associate law. AL is not ohmic. AL, I am assuming associate law. And this is, hey, you understand what I'm talking?
Yes, sir.
Yes, sir.
Yes, sir.
Do not follow AL. AL means what?
Associate law.
Associate law.
I'm just for your understanding. Okay, good. So it follow the associate law, and that does not follow the associate law. Means if you come here, follow the associate law means if you go for the power here, this power will give you V into I. If it follows the associate law, then power will be positive. That's the thing. This is positive power. And if it does not follow the associate law, the power will be negative, V into I, but it is negative. It follows the associate law, it does not follow associate law means, you look at it, the current is flowing from the positive to negative. This is the normal. High potential to low potential. Water pressure higher here, lower here, then current flow. No, you know that. Likewise, in this case, the lower pressure, higher pressure, because negative to, this is not the way current flow. So it does not follow the associate law. You understand it?
Yes, sir.
Yeah. So if the current enter, look at it, current entry point to the element or branch, this is the branch. Branch means any element, resistor, capacitor, inductor, battery, current source, whatever. But all what you need to understand, if the current enter into the branch and that is positive polarity of the voltage drop across it, then it follows the current entry point is having the positive voltage sign. This is what is the main thing, remember. And current entry point is the negative sign, then it does not follow the associate law. If it is positive, yes, it follows the associate law. If it follows the associate law, then voltage and current multiplication give you the positive power. I mean, it should be in the positive in the equation. And if it's something like that, then voltage current is having a negative in the equation. This is the associate law. Let us go and apply the associate law here. If you apply the associate law here, what is the power here? If I ask you, what is the power here? Okay, here, can you tell me? Power 5 volt means, look, current is 2 ampere and voltage is 5 volt. So 2 into 5. Now, will there be any positive sign or negative? That's a question. What will be the sign? Positive or negative?
Negative, sir.
Why negative? Because the current enter into the
Entering into the negative
side. Then it will be negative. All of you try to get it. This is negative because current enter. Oh, we are going to have a 10 minutes time. Okay, now you try to get my point. This is the way we can get it as a negative. Understand it? You can remember or forgot it.
Sir.
I show you already here. Yeah, here.
Sir,
Can you see?
I
Yeah,
have,
go.
I have a class, sir. Actually, sir.
Oh, yeah, those who have a class, no problem. You can jump because the video lecture will be uploaded. So you can see the video. Now, you try to get my point, those who are here. Just I'm going to finishing this thing. Now this is negative, so we are following this thing because it is negative, so it does not follow the associate law, means it is negative sign, we are getting there. So you are getting, so what is that value? Is a negative 10 watt. Similarly, this one will be what? This one will be also negative, isn't it? This current enter,
Yes, sir.
enter into this thing. So it is 3 into 2, but a negative sign coming. So you are getting here minus 6 watt. So this is minus 10 watt. This is minus 6 watt. Minus 6 watt. This is minus 10 watt. Adding these are the negative power. And if you go here, I square R, I can be negative also, always positive. This is coming positive. But if you go for associate law, if you apply, that is V into I, if you want to apply V into I here, hey, it is what actually? V into I means what? What is the voltage? I'm just going to ask you, what is the voltage and current? Tell me. What is the voltage here in this resistor? What is the voltage across resistor? Isn't 8 volt? Hello?
Yes, sir.
8 volt. This is 5 volt, 8 volt, and this is 3 volt. From the KVL, we found V2 equal to 8 volt, right?
Right, sir.
So
Yes, sir.
8 volt. So it is V into I means 8 into and a current. Resistance power also can be found from the VI because V is given. So V is 8 and I is what? 2.
2.
So does it follow associate law or not?
Follow, sir.
Yes, because 2 ampere current is flowing through the positive terminal. So it follows the associate
Yes,
law.
sir.
If associate law, it follows means it is plus or minus?
Plus, sir.
Plus.
Plus,
So it is plus 16 watt. So, and always remember, whenever resistor is there, if the current and resistance given, always follow the I square R. And I square, and I square R is positive. Always positive. Is it okay?
Yes, sir.
Because whatever I cannot be, R is always positive, I can be negative. If I is minus 2 square is plus 4, right? I square means always negative will be always positive. So even the current is negative, doesn't matter. That's why a resistor always positive. Always the power absorbed by the resistor is always positive. It cannot be negative. Now listen, even associate law also say that this is positive. Now all the negative power P delivery are all negative, negative 10, negative 6. All the negative power are delivered and all the absorbed power are positive. Absorbed power is positive, that is positive 16. So like that, if there is any other positive, all add together. So all the negative power you add together, all the positive power you add together. Then positive power and negative power you sum together will be 0. That's what we can say the summation of P means P absorbed plus P delivered. So all positive and all negative power will be equal to 0, right? So you can see that minus 16, minus 10, minus 6 plus 16, all will be equal to what? 0, isn't?
Yes, sir.
So this is one way we can say that yes, summation of all these things equal to 0. Now if you apply the same associate law here, then you will not be confused. For example, here what is the power? Here the power will be what? 5 into, can you tell me what is the power? 5 into
0.5.
0.5 and negative or positive?
So negative.
Yes, it does not follow the. Okay, I'm sorry for this is the last. I'm going to finish it and then finish. Okay, just one thing I would like to tell you if you are online with me. This is the power you are getting is a negative 2.5 and this one is positive because if you go here for the resistor power, it is P 4 ohm resistor is equal to V into I. V is what? What is I? What is V? If I ask you, V is 2 volt, right? The resistor voltage,
Right.
and current is 0.5. So, and it is following the associate law. So 2 times 0.5 is positive. So what is the value coming is 1 watt.
1.
Or I square R giving you 1 watt. Always positive. Resistor is always positive. It cannot be negative at all. So it is 1 watt positive voltage, positive power you got. So P absorb, and okay, fine. Now you come here, the last one, this one. So this one is a V into I, 3 into 0.5 you have written. Now is it positive or negative?
Positive.
Why positive? Because
Current entered through the positive terminal.
so it is following the associate law or not?
Yes, sir. Following the associate law.
Okay, this is following the associate law, that's why it is positive. Do you all understand it? This part
Yes,
is
sir.
very
Yes, sir.
important. This is the only critical thing. The 3-volt battery polarity we change. Now it follows the associate law. If it follows the associate law, then the power is positive power here, because voltage into current will be positive because it follows the associate law. But in the 5-volt case, it is minus. Because why? Because the current is flowing through minus, so it does not follow the associate law. That's why it is negative. And it follows the associate law, and that's why it is positive. These are the two different things, 5-volt and 3-volt battery. And resistance is always there. So you are getting the positive power over here as 1.5 watt, and the delivery power you are getting minus 2.5 watt. So the delivery power is here. We can say, I'm writing here, look at it. Delivery power is the negative power, which is minus 2.5, and absorb power is positive power. Positive power is what? One is the resistor power, which is 1 watt. Another one is the 3-volt battery power, which is 1.5 watt. You got the point?
Yes, sir.
Okay, what is the total value?
Yes, sir.
1 plus 1.5, what is that?
2.5.
Right. So you are getting 2.5 watt as a positive power, is the absorb power. Now your summation is the total summation. Summation equal to what?
Sir, absorbed plus delivered.
Equal to what?
Sir, power absorbed plus power delivered is equal to 0, sir.
0 is a power delivered. Power absorbed plus power delivered equal to 0, because power absorbed is your 2.5, power delivered is minus 2.5. So plus 2.5 is equal to 0. That means your absorbed power equal to delivered power, which is also proved. So this is how actually you are getting it. So all of you told me last time that, sir, minus 1.5 watt will be negative. This is the wrong way. Actual negative is actually the 2.5 is negative, but this one is positive and that one is positive. Now look at the thing. All of you, please come to understand one thing and then go. The difference between these two, the previous page, if I go here, 3-volt battery polarity, and here 3-volt battery polarity is a swap or interchange. Other than that, everything is same in the circuit. Because of swapping, the current flow is changed. Earlier it was 2 ampere, now it is 0.5 ampere, right?
Yes, sir.
Okay, because of that, actually all the changes are coming here. Now you look, these two circuit, I'm sorry, these two circuit gives you what? The 3-volt, look at it, this is the final bottom line. Bottom line is, in this in the previous case, the battery was delivering the power, 6 watt power it was delivering. The power it delivered 6 watt to the circuit. And in this case, the battery is absorbing the power 1.5 watt, because we changed the polarity. That's why it is absorbing the power. But earlier it was delivering 6 watt to the circuit, but now it is absorbing the power from the circuit. You understand it?
Yes, sir.
That means this 3-volt battery is nothing here. Here work like your mobile battery charging. So you are connecting your mobile battery here, means your mobile battery is charging the battery. That means it is absorbing the power in your mobile battery. That is the thing you can imagine like that. That battery can be working as a absorb element, a power absorbing element, like your mobile battery. When you are charging, it is doing that. But when you disconnect your mobile. Now your mobile circuit is working. That time your mobile battery is delivering the power to your mobile circuit. That time mobile battery is delivering the power and your mobile circuit is absorbing the power. You got the point?
Yes, sir.
Yeah. So this is the way we can compare this thing. And I'm not going to tell you anything. I'm just asking you, you do it by yourself. You look at this problem by yourself. Next class, I'll show you. This is a solved problem and it is related to this actually. You look at it. Oh, how many elements are here? 1, 2, 3, 4.
4, sir.
So 1, 2, 3, 4. 4 power. 1 power absorb, deliver, absorb, deliver. Now with this concept, if you apply, you can find, and the summation is equal to 0. That means all negative power and all positive power are equal and it's equal to 0. This is what. In this problem, main thing is I ampere, 8 ampere. This one you have to find it. That the current is 8 ampere. How? This is the question here. I'll solve these things in the next class so that you can understand it much more clearly. You just go through this problem before coming. It will be much more easier for you. Hey, that's the end, and we'll go through some of the slide, 2-3 slides, which I could not complete. Next class I will do that. Now, you know that next week Sunday you do have class test 1.
Yes, sir.
I have already uploaded in the BUX announcement, City 1. Have you seen that?
Not yet, sir.
Yes, sir, because you never gone there. I am not going to send email. This is the university system. All of you look at the BUX. I have already announced it, City 1 on Sunday. All of you please go through that, and no more email. All of have to go through that. Even the link for the online class also will be there. So the rules and regulation for City 1 is written clearly over there. If you have any question, you can talk to me next class or whenever. I think that should be fine. And this problem is very important for you to answer in City 1 also. So everybody should be careful about it. And very KVL, KCL understanding is required. So next class, we are going to finish, and syllabus will be up to next class for City 1. So all of you please try to solve and understand the problems that what I have already uploaded. I have uploaded some practice problem, everything on the BUX. If you cannot find, you please let me know, and keep in touch with me for any problem. Okay, anything, thank you very much. And if you have any personal problem, or solving problem, cannot understand this, that, let me know. I'll give you time for that, no problem, during the consultation time. Okay, thank you very much. So far, so good. If anybody got any question, can ask me, or you can go away, no problem. Anybody got any question, can ask me. Otherwise, we can finish the class. Do I have any question? Hello? No question?
No, sir.
Okay, thank you very much, because I have another class after this, so I think I have to go for it. Thank you very much. See you next class. Thank you.
Thank you, sir.